Ladies and gentlemen, welcome back for our last live presentation of this afternoon. We are pleased to welcome back Roctool. Their presentation will highlight innovative molding processes such as heated platens, showcasing a mix of high performance and energy savings. To talk about Roctool's heating technology, we are very pleased to welcome back Mathieu, the CEO, and Edouard, Philippe, the Composite Business Development Manager of Roctool. Gentlemen, the demonstration floor is yours.
Thank you, Joanna, and good afternoon, everybody. Thanks for spending some time with us. My name is Matt, and Edouard will be co-hosting this demonstration. And over there by the machine is Hugo, is one of our engineers in charge of running this demonstration today. So a few words about Roctool. Roctool is a heat and cool provider. We provide heating system, cooling system, and molding technologies for compression molding, injection molding, blow molding. Obviously, we're at the JEC, so we will focus on composite. For this year, we decided to focus on thermoplastic, but we also mold thermoset materials. Obviously, with the ability to go high heat, we focus on, in general, on thermoplastic materials. So, a few words about Roctool. We have engineers, and they spend time in evaluating what is the best heat and cool process for your applications. So in the aerospace, in the automotive, in sports and leisure, whenever there's a need to have a flexible heating process, a heat and cool process, also about surface quality, about energy consumption, and obviously about productivity, this is what we focus on with our customers and our molding technologies. We're using induction heating. It's our core technology. So induction is a safe technology. I'm sure you know induction from many different industries in heat treatment, welding, and brazing, and some other conventional methods using it. But we're using induction for molding. And this year, we decided to focus on a new configuration where we will use induction for a heat platen. And then we have interchangeable inserts, mold inserts, that we place on this superheated platen by induction that can be heated and cooled down. So when you're a composite manufacturer, it gives you great flexibility because you can have a wide spectrum of temperatures and different kind of cycles that you can program yourself. And to give you, before we start molding, Edouard will explain to you the different systems we have over there and what we will be showing today.
Thank you, Matt, for this introduction. So we'll have the pleasure today to present you a new standard for compression molding for mass production with guaranteed performance. So we integrate our system in a press machine. You are here our Roctool Induction Dynamic Saver. It's a heat and platen. And on the top of this heat platen, we fix aluminum mold. It's a coaster mold, coaster parts. With a cavity and a core. So we have placed, in this case, a configuration with aluminum mold, but it can be also used with steel or nickel, different other material. So in this Roctool Induction Dynamic Saver technology, we have induction system. And to use this technology, we need to have our equipment. So on the right of the part of the demonstration, you have our Roctool generator. It's a dual zone equipment. So to be able to manage separately the top and the bottom of the RADDS system. So we have one connection for the top, second connection for the bottom. And with these induction generators, we have also two cooling units because we have also integration of cooling channel inside the hot plate. And one is dedicated for the mold. It's a C6 equipment with the capability to deliver 100 liters per minute at 20 degrees from a chiller group. And the second one is due to our generators need to be cool. So Hugo, we can start this first live demo. And for this live demo, we use a UO material.
Yes, so the UHO material is a non-woven. Typically, for that demonstration, we want to show every time we change the kind of reinforcement. So we have one that's a non-woven, a woven. We have a chopped tape. We have natural fibers, carbon fiber, glass fiber, just showing that with the induction heating, you can have that flexibility from one material to the other. This material comes as a mat. So you're looking at a non-woven with polypropylene, so PP, and we will use 230 degrees Celsius in the heat platen. And then by conduction, we're going to heat up the tool insert. By compression, hold, and then cool down and make the final part.
So we manage the process with this interface controller. It's a RT21. So we can manage, as I explained separately, the top and the bottom of our IDS technology. You see the temperature is growing. We start to connect the heating induction equipment. So we need to reach 240 degrees in less than 3 minutes in this configuration. So you see also that due to we use thermoplastic composite material, we start to reduce the cycle time, and we use for this application 50 kilowatt per side to be able to reach the maximum of temperature in a short time.
So here for the show, we're doing one part, and then later another one, and then later another one. So it's not really a manufacturing environment. We're doing demonstration. But let's look at what we would do if we were in production, right? So if we were in production, we would keep the heat platen to some level of temperatures in between cycles, because the insert on top of it is being cooled down by itself, so it gives you the speed. But then in between, we just need a little bit more power to get back to the temperature to be molding. So the energy consumption in between the two steps is very low. It's 5 to 10 kilowatts to keep the heat pattern in temperature. So think about it, if you were in a more conventional production environment, you would have oil heaters or maybe electrical cartridge on a hot press. Very difficult to go from one temperature to another quickly. Same thing that, let's say it's Friday night, Monday morning, there's a big batch of production that has to be done. A lot of manufacturers, they will keep everything hot on the weekend because Monday morning, it would take too much time to reheat everything. So this ability with induction to turn off everything in between production batches is a big advantage. This needs to be measured in terms of energy savings. And that's what we show here, because every time we start a demonstration, we start from zero. There's no preheating, there's no oven with transfer of material, or I don't know what other heating system. So 100 kilowatts to heat both sides, 50 kilowatts, 50 kilowatts. And then once you're done with that, only 5 to 10 kilowatts to keep hot and to maintain the platen to a lower temp.
So now, after 2 minutes and 50 seconds, we reach 240 degrees. And now we start to keep the temperature constant at 240 degrees during 1 minute. So for that, we use the generator just to push a peak of power, just to keep the temperature at the same value.
So the thermocouple we use, they're on the heat platen, where we can measure temperature. But we could also have, here we don't have because it's tiny parts for demo, but you could also have sensors in your insert to monitor live temperature of your mold surface in connection with your material.
So we have again a few seconds before to start the cooling. Due to the material, we don't need to spend a lot of time at constant temperature. We melt the polypropylene. We apply the pressure to consolidate the material in the cavity. And so immediately now we can start to stop the heating immediately. As soon as we stop the heating, we stop the energy consumption about the heating, and we start to cool. We push the water inside the circuit to reduce quickly also the temperature.
So in terms of size, Today, this is 600 by 400, I think, the size. And we recently did the installation of same technology for 2.5 meter to 1.5 meter. Okay, so very large platen for much larger press machines and so on. So there's not really a limitation in terms of size. It's more about finding what you need for your specific application. And also the heat level. Let's talk about the heat level. The induction is like a 200 Celsius or 250 Celsius is actually low heat for induction. And typically for a lot of manufacturers, 250 already, oh, what am I going to use, what kind of system, and so on. So we can go 350, 400 plus. We have projects with PEAK or PPS and other PEI, also high heat resin that require that level of temperature. So induction gives you this flexibility in the temperature that you can reach.
Clearly, we can adapt the RIDS technology with a very large different materials. So for this live demo, we present the use of Hayate material, which is a non-woven recycled carbon fibers, with the particularity to have the carbon length between 50 to 100 millimeters. It's a good material also for the droppability and the formability with very good mechanical performance. So now I think we reach, again, 10 minutes, 10 degrees before to reach the demolding temperature. And as soon as we can open the mold.
So one thing, the time we open up the press, with the high heat molding, the resin inside the material will migrate to the surface and we'll get this very nice surface finish. So you'll be able to see that the resin will cover all the fibers. That's a sign of a good consolidation, sign of a good resin flow. It means that the part is fully consolidated and there's no lack of temperature and so on.
So now we open the press and we could demold the part. So for this configuration, we make the demolding manually. But of course, we can integrate ejectors
with little pins and so on. And for the show, we made 4 different inserts because we wanted to combine with some other partners, Saint-Gobain, which help us with the 3D knitting of materials, and the one we do now to combine parts together and make like a little, little phone holder like this. So that's what we wanted to demonstrate during the show with this. So the time I'm going to circulate parts so that we save some time. The times he demolds. Oh, here it goes. So we can see, we can circulate different ones. So that's the one that is just coming out. You already know. So that's the non-woven version. I'll circulate also the chopped carbon, chopped tape version from White Saver as well at the same time. I'm not going to give you the base material because it gets very itchy. So I don't want you to touch this. And in terms of performance, it's surprising that non-woven, because it's long fiber, even if it's not a woven material, it's incredibly stiff. We've been surprised. We've been running it on other parts. And the level of stiffness we reach with this is just surprising. We would expect only woven materials to do that, but non-woven, they're quite surprising.
So we restart a new cycle with the similar material.
Yeah, and at the same time, we can. The thing about the cycle time, it's pretty fast. So maybe in the meantime, if you guys have any specific questions about that first molding shot, please shoot your questions. We're here for that. Nothing to hide. Yeah, I'm going to say your question. So you're asking if the heat platen heats up and then transfer to the inserts. Absolutely. But the insert has a cooling network and the platen as well. And that's why we can be dynamic in playing with the two, the platen and the insert. That's why it's fast.
So we show you also during the live demo several possibilities to use our technology with very different material. Just a quick explanation about our different other materials. So you explain the material from Saint-Gobain, which is a 3D preformed textile. So it's a mix of thermoplastic resin and glass or carbon fibers. The interest is, of course, to have a 3D preform to easily lay up your mold in a short time and combine with our technology to obtain a very short cycle time, completely with the possibility to lay up and demold the part in a few minutes. We show you also material come from Rainbow company. It's a Chinese company. They produce pre-preg material with, for example, in this case, nylon resin. It's a carbon weave, but you have also a range of unidirectional carbon fibers. So for this application, and we, during the, yesterday, we show a shoe sole mold, and we use this different configuration to produce this sample. And also, we use also waste saver material. So it's a German company. They supply, based on a pre-preg tape material, a weave, a very high performance weave. It can be done also with carbon, glass, or natural fibers. And with this different configuration, we are also show that we can produce similar parts with different materials. So in this case, it's flax fibers with polypropylene resin. And with this application also, we use chopped carbon fibers that we make with the custom mold and with PC resin and recycled carbon fibers.
So going back to your question, we have this little demo here to see actually our system where we have inductors and also a cooling section. So we have this ability to heat cool. And all the inductors are designed and made by Roctool. They're fully insulated. And we have a design know-how where to integrate the heat and cool based on the mold or based on the size of the platen. So I think we come to an end. This is finishing the second shot, but if there's any other questions, that's the good thing about making parts fast, is that it's fast compared to maybe some other longer cycle time where we would make the parts right now. But yeah, if there's any more questions on your side, don't hesitate. Maybe you have questions, Joanna. I know you do.
Yes, I definitely have some questions. Can you tell me what are the key advantages of this new technology, Mathieu?
Well, if I summarize, I would say number one is the flexibility of molding, because then you know you have a good heat base, and in a manufacturing environment, it's very essential. We think that there's a lot of work done on new materials, new reinforcements, but then if in your lab or in your manufacturing house, it's an old press with an oil system, a lot of those new materials will be difficult to process because of temperature limitation or cycle time limitation. So number one, flexibility. Number two, energy consumption. If I'm trying to do this with an electrical cartridge or oil, I'm going to struggle and I'm going to use a lot of energy, especially when I don't manufacture, when I don't use my press. So that's a lot of saving. And number three, I would say the ability to go to high heat temperatures. So if I have a project coming in, someone says, oh, actually that material is going to be nylon 12, or this one is PPS, I know I've got what I need. I'm not going to have to revisit my whole process down the road thinking, oh, now I'm too limited because I have this technology and so on. So I would say those are the three advantages.
Okay, great. And can you explain perhaps why you chose this demonstration today?
So we chose demonstration to show the variety of reinforcements, and that once you have heating, actually, doesn't really matter what you're molding. I shouldn't say that. All of them are good materials, but for us at Roctool, it's just about finding the right temperature, and whatever is in the tool then will be compressed and molded, and we will reach the temperature that is needed. Same thing with thermoset. We can also use this technology for thermoset. So we don't have a limitation for materials.
Okay, fantastic. Thank you so much, gentlemen. If you would like to continue the conversation, don't hesitate to come up and see them, see their molds, or to talk to the whole Roctool team, which is right next door. Their stand is right here. And they will be back again tomorrow at 11:30 a.m. for their last demonstration of the day. The live demonstration area will start again tomorrow at 10 a.m. with Aerovac Composite 1. So don't hesitate to come join us again. And otherwise, we wish you a very lovely evening at the show, ladies and gentlemen. Thank you so much.
Thank you. Thank you very much.
Thank you.
Thank you.